Here are some more examples of taking tables of values and finding the equations of those tables that generated those tables. So for each of these, we're going to take a look at what we looked at last time. How fast is x increasing? How fast is y increasing? For all of these, the x values are increasing by 1, by 1, by 1. For everything on the page here, everything on the page here, everything on the page here, except for this one. This is one that we need to pay attention to. Here's one where our x values are increasing by odd amounts, and m, our x values are also increasing by odd amounts, but the rest of them seem to be going up one at a time. Now, when we're looking at this, we want to figure out how much the y is changing by each time. So 3 to 4 to 5 to 6 to 7. Each time we're going up by 1. So if x is going up by 1 and y is going up by 1, our equation could be y equals x. And so just by 1, that's 1x. And how do I get from x to y? It looks like I can add 2. Add 2, add 2, add 2, add 2. So I can write y equals x plus 2. For b, I'm looking at my y values here. I'm going down by 4, down by 4, down by 4, down by 4. So I could say y equals negative 4x. The negative 4 is that negative 4 there. And what happens when x is 0? When x is 0, it's going to be, well, negative 8, negative 4, y is also going to be 0. So I could write in plus 0, or I could ignore it. Normally we ignore it. For c, looks like our y value is going down 1, down 1, down 1, down 1. As we go down 1, that means our slope is negative x, or negative 1x. And what would be the value when x is 0? So 5, 4, 3, 2, 1, 0. 0, 1, 2 looks like 3. So negative x, or negative 1x plus 3. For d, we've got our y value going up by 3, by 3, by 3, by 3. So we would say y equals 3x. And what if x was 0? We would keep coming down here to negative 3. So 3x minus 3. And you can always check these by substituting the x values back in, make sure that a random one works. For e, looks like our values are going down by 5, down by 5, down by 5, down by 5. So I'd write y equals negative 5x. And what if x was 0? Well, if I went in this direction, up by 5, 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 we would end up at positive 2. So I'd write y equals 5x, negative 5x, sorry, plus 2. For f, if I look at my change in my y variable here, I'm going down by 1, down by 1, down by 1, and down by 1. So I would write y equals negative 1x, or just negative x. And if I write y equals negative x, I need to figure out what happens when x is 0. Here it's just on the chart. It just told me. So it's 7. For g, my y is going up by 1, up by 1, up by 1, up by 1. So this is down by 1, up by 5. So I would write y equals 1x, or just x. And what happens when x is 0? Well, it's right there. Y is negative 5. For h, we got up by 2, up by 2, up by 2, up by 2. So I would write y equals 2x. And what happens when x is 0? 7, so 9, 7, 5, 3 should come. So I'd write 2x plus 3. For I, j, k, and l, we'll take a look. For I, it looks like we're going up by 10, up by 10, up by 10. So I would write y equals 10x. And what would the value be if I had when x is equal to 0? So 49, 39, 29, 19, 9. Looks like I subtract 10 and I get to negative 1. So we'll do 10x minus 1. For j, it looks like we're going down by 15. Down by 15, down by 15, yes. So I'll write y equals negative 15x. And what if x was 0? If I keep going one step down that way, I get to positive 2. So coming down, I'm going down by 15. As I go up this way, I'm adding 15, adding 15, adding 15, adding 15, adding 15 to get to there. For k, looks like we're going up by 6, by 6, by 6, by 6. So y equals 6x. And where would we be when x is 0? If we go 12, 6, 0, looks like the next step will be negative 6. We just extrapolate a little bit to get that last term in each of these. For L, it looks like we're going up by 1, up by 1, up by 1, up by 1. So y equals 1x, or just x. And where would we be when x is 0? So negative 6, negative 7, negative 8, negative 9, x minus 9. Now, on this last line here, there are 2 to watch out for. I'm going to do n and p first before I do m and o. For n, I've got my y going down by 7, down by 7, down by 7. So I'll write y equals negative 7x. And when x is 0, it looks like I would be at negative 1. So negative 7x minus 1. For p, looks like we're going down by 1, down by 1, down by 1. So I'll write y equals negative 1x, or just negative x. And where would we be when x is 0? Looks like negative 10, negative 9, negative 8. That's the pattern there. Now for m and o, those are the ones where the steps are not equal, right? We're going up here by, from 1 to 4, we're going up by 3. Up by 3. And there's no reason for this other than that's just what's in the table. So here, our y value is going up as well. And it's going up by, looks like 12. So each time we're going up by 12. So if I'm looking for 12 steps up for every 3 steps over, we can reduce that fraction, 12 over 3. So 12 up and 3 to the right on a graph. 12 over 3 is just 4. So I would write y equals 4x. That's my slope. For every 12 that I go up, I go over 3. That's the y value we could call the rise, and the x value we could call the run. In all of our other examples, we've been dividing by 1, and dividing by 1 is something that is so easy to do, we just don't ever write it down, because it's always the same number. But here, we need to remember about it. So I've got my slope 4x. For every 1 step I go over, I go up by 4. Or every 3 steps I go over, I go up by 12. I still have to figure out what happens at x is equal to 0. But I already know that it's 4 each time. So from 1 to 0, that's down 1 step, which means I should go, left 1 step, which means I should go down by 4. So down by 4 from 9, 9 minus 4 is 5. Things like m and o, I feel, are much easier to do on a graph. Certainly possible this way. Last one here for o. On our x, we're going up by 2 each time. And on our y, looks like we're going up by 16 each time. So if we're going up by 16 and over by 2, if we're talking about our rise and our run, or our change in y and our change in x, 16 over 2 is 8. So I can write y equals 8x. And what happens when x is 0? Well, if I go down 2, I should also go down 16. 20 minus 16 is 4. So 36, 24. If I kept going, maybe to negative 12 and so on. These are just some examples of ones in case you need some guidelines or template or something to work through.